Hello students, I hope you all are fit and fine. And the topic of today's class is motion. Introduction. In everyday life, we see some objects at rest and other in motion. Birds fly, fish swim, blood flows through veins and arteries and car move. Atoms, molecules, planets, stars and galaxies are all in motion. We often perceive an object to be in motion when its position changes with time. An object may appear to be moving for one person and stationary for some other. For the passengers in a moving bus, the roadside trees appear to be moving backwards. A person standing on the roadside perceives the bus along with the passengers as moving. However, the passenger inside the bus sees his fellow passenger to be at rest. What do these observations indicate? In this chapter, we shall first learn to describe the motion of objects along a straight line. We shall also learn to express such motions through simple equations and graphs. Later, we shall discuss ways of describing circular motion. Describing motion. We describe the location of an object by specifying a reference point called the origin. Motion along a straight line. The simplest type of motion is the motion along a straight line. We shall first learn to describe this by an example. Consider the motion of an object moving along a straight path. The object starts its journey from O, which is treated as its reference point. Let A, B and C represent the position of the object at different instants. At first, the object moves through C and B and reaches A. Then it moves back along the same path and reaches C through A and B. Magnitude. There are certain quantities which are described by specifying only their numerical values. The numerical values of a physical quantity is its magnitude. Displacement. The shortest distance measured from the initial to the final position of an object is known as the displacement. Two different physical quantities, the distance and the displacement, are used to describe the overall motion of an object and to locate its final position with reference to its initial position at a given time. Uniform and non-uniform motion. When the object covers equal distance in equal interval of time, it is said to be in uniform motion. In our day-to-day life, we come across motion where objects cover unequal distance in equal interval of time. For example, when a car is moving on a crowded street or a person is jogging in a park, these are some instances of non-uniform motion. Measuring the rate of motion. We describe the rate of motion of such objects in terms of their average speed. The average speed of an object is obtained by dividing the total distance travelled by the total time taken. This is average speed is equal to total distance travelled upon total time taken. If an object travels a distance s in time t, then its average speed v is equal to s upon t. Speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object's speed, direction of motion or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms of average velocity. It is calculated in the same way as we calculated average speed. In case the velocity of the object is changing at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity upon 2. Mathematically, v is equal to u plus v upon 2, where AV is the average velocity, u is the initial velocity, and v is the final velocity of the object. Speed and the velocity have the same units, that is ms to the power -1 or meter per second. Rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any time interval is 0. However, in non-uniform motion, velocity varies with time. It has different values at different instants at different point of the path. Thus, the change in velocity of the object during any time interval is not 0. Can we now express the change in the velocity of an object? To answer such a question, we have to introduce another physical quantity called acceleration, which is a measure of the change in the velocity of an object per unit time. That is, acceleration is equal to change in velocity upon time taking. If the velocity of an object changes from an initial value u to the final value v in time t, the acceleration a is equal to v minus u upon t. This kind of motion is known as acceleration motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. The SI unit of the acceleration is ms to the power -2. In next class, we will study about the graphical representation of motion. Thank you.